Hello student, this is our third lecture of Ionic Equilibria. In last lecture, we have seen about the Oswald dilution law for weak acid and weak base. This Oswald dilution law is depend upon the acid-base concept of Arrhenius, right? So on the basis of that, the Oswald dilution law for weak acid is the degree of dissociation of weak acid is inversely proportional to the square root of concentration, or we can say it is directly proportional to a square root of its volume, right? In what amount of solution? In 1 mole of weak acid solution. So in terms of equation, we can write this: alpha, that means degree of dissociation, is equal to the square root of Ka upon C, or in terms of volume, the equation become alpha is equal to square root of Ka into V, right? This is the equation for Oswald dilution law for weak acid. Similarly, we already learned about the Oswald dilution law for weak base. So again, Oswald dilution law for weak base is degree of dissociation of a weak base is inversely proportional to the square root of its concentration, and it is directly proportional to the square root of volume of solution containing 1 mole of weak base. Understood? So similar equation is here, like weak acid, again alpha is equal to square root of Kb upon C in terms of concentration, and in terms of volume, the equation is alpha is equal to alpha is equal to square root of Kb into volume. Okay, this is called as the Oswald dilution law, which we have already discussed in last lecture. Now, today we are going to discuss about the next topic, and the next topic is autoionization of water. The word auto itself gives its meaning. As we know, auto means itself, right? Auto means itself. And the ionization, that means dissociation. For what? Water having a autoionization. That means water itself undergo ionization. Okay, and this process is called as the autoionization. As we know, the water is continuously undergo dissociation, but the rate of dissociation is very slow. Okay, so consider water molecule is here, and this water molecule loses H plus ion. Okay, this water molecule loses H plus ion. If it undergo dissociation, then one of the water molecule loses H plus ion, right? Because as we know, whenever water is undergo dissociation, what happens? It forms H plus and OH minus ion, right? It forms H plus and OH minus ion. Understood? So if one water molecule loses H plus ion and another water molecule accept H plus ion, according to which concept? It is proton donor and acceptor concept. And as we know, proton donor acceptor concept is nothing but a Lorry-Bronsted concept. Okay, so apply the Lorry-Bronsted concept here. If this H plus ion donates proton to this H plus ion as through this water molecule, so formation of H3O positive ion takes place, and another one is hydroxide anion takes place, right? So this is act as a proton donor, and this water molecule act as a proton acceptor. So as we know, according to Lorry-Bronsted concept, the species which donate H plus ion called as acid, and the species which accept H plus ion called as base. Okay, so one of the water molecule act as acid and another water molecule act as a base, and we get this hydronium ion with hydroxide ion, right? In some books this reaction is also available. That means water molecule is undergo dissociation, forms H plus and OH minus ion. So from this, both reactions are same. Both reactions are correct. Both reactions are correct. This first reaction is correct. Also this second reaction is also correct. But more correct is this reaction. Okay. This in the form of hydronium ion and hydroxide ion. If we write this reaction, then also correct. Okay. So this water molecule is continuously undergo dissociation. One loses proton, another accept proton. So formation of this hydronium ion takes place and hydroxide anion takes place. And this process is called as autoionization process, and this process is a spontaneous process. Okay. So how we define the autoionization of water? The process in which water molecules spontaneously form low concentration of H plus and low concentration of OH minus ion by proton transfer from one water molecule to another water molecule. Correct? So this process is called as autoionization process. As you can see on screen, in diagrammatical representation, you can see here, this is one of the water molecule, right? This one is the one of the water molecule, and this is another water molecule. What happened here? The second water molecule loses its lone pair and donates its lone pair because of oxygen atom acquire two lone pair. So that's why oxygen having a tendency to accept proton, right? So accept proton from another water molecule. So it gives H3O positive ion. Because of losing its lone pair, it acquire positive charge. Oxygen acquire positive charge, and it loses H plus ion. So here hydroxide anion takes place, right? And this process is called as autoionization process. Now, as you can see here, the bond in between this reaction, and or we can say in this reaction, the bond is reversible bond is here. See here, this bond is very important in this reaction. So that means we can say this water molecule is forms, that means the losing of proton, or this reaction, this autoionization reaction forms equilibrium condition after some time, right? Because whenever this type of bond is present in this in any reaction, that means this is reversible reaction. And as we know, in reversible reaction there are the formation of equilibrium condition takes place at some time, right? So this reaction also forms equilibrium condition after some time. So as we know, like Oswald dilution law for weak acid and weak base, in that we are already write the dissociation, the equilibrium constant equation for weak acid and weak base, because this reaction is also reversible reaction. So in this reaction also we can write the equilibrium constant for equilibrium equation for this reaction. Okay. Now, because of this reversible arrow, we can write the equilibrium constant for the ionization of water, right? And as we know, how will you write the ionization constant equation? As we know, कैसे लिखते हो? Concentration of product upon the concentration of reactant. Equilibrium constant is the ratio of concentration of product to the concentration of reactant. So what are the what are the products and what are the reactants? Products are hydronium ion with hydroxide anion, and reactants 2 water molecule. Write down the equilibrium constant equation for ionization of water. K stands for the ionization equilibrium constant, right? So it is the ratio of concentration of product. So H3O positive and OH minus ion are the products upon the concentration of reactant, and 2 water molecules are the product reactant. Okay, so and its concentration is this. That means called as the concentration of water molecule. So 2 water molecules, so that's why 2 as a square. Now arrange this equation. We can write this equation in this form also. Arrange this equation. ये जो डिनोमिनेटर टर्म है इसको अरेंज कर दो तो ये इधर चली जाएगी, राइट? ये इधर चली जाती है. सो द नेक्स्ट इक्वेशन बिकम K into K is the equilibrium constant. K into concentration of water equal to concentration of hydronium ion into the concentration of OH minus ion. Okay. Now listen carefully, student. Now next part is the very, very important part. As we know, the water molecule loses. What happened in this reaction? Water molecule forms H plus and OH minus ion, right? H plus and OH minus ion. This is called as the dissociation of water now. This is called as the ionization of water now. So look, if 1 mole of water molecule is here, okay, 1 mole of water molecule is here, then it forms H plus and OH minus ion, and experimentally it is proved that the concentration of this H plus ion is 10 to the power minus 7, and the concentration of this OH minus ion is also 10 to the power minus 7. It is experimentally found that the concentration of H plus ion is found in the that is 10 to the power minus 7, and also hydroxide anion 10 to the power minus 7 concentration. Okay, so in 1 mole of water molecule, now 1 mole of water molecule means how much molecule? 6.022 into 10 to the power 23. That is Avogadro's number. 20 to the power 23 molecules, right? So in 6.022 into 10 to the power 23 molecules, in this 10 to the power minus 7 H plus ion concentration is there, and 10 to the power minus 7 OH minus ion concentration is there. That means it is very, very, very negligible. So it is na ke barabar, right? So it is na ke barabar in 1 mole of water molecule. Okay. Now consider मैं आप लोगों को एक एग्जांपल देती हूँ कि समुंदर में वाटर रहता है ना, राइट? तो समुंदर में से अगर किसी को बोला जाए कि एक बकेट पानी लेके आओ, ठीक है? तो कोई तो भी एक स्टूडेंट बोलो या एक्स पर्सन एक बकेट लेके गया है और पानी लेके आ गया, तो उसने अगर 1 बकेट पानी लेके आता है तो पूरा समुंदर सूख जाता है क्या? ऐसा होता है कभी कि एक बकेट उसमें से निकाल लो या 10 बकेट उसमें से निकाल लो ओशन में से, समुंदर में से, तो समुंदर पूरा सूख गया? ऐसा कभी सुना है? नेवर एवर, राइट? मतलब आप समुंदर में से एक बकेट को रिमूव करो या 10 बकेट को रिमूव करो, समुंदर के पानी में कुछ भी फर्क नहीं पड़ रहा, बराबर ना? दैट मीन्स यहाँ पे भी सेम कंसेप्ट अप्लाई होता है कि इफ water molecule in 1 mole of water molecule 6.022 into 10 to the power 23 molecules are there, right? So उसमें से only 10 to the power minus 7 more concentration अपने को मिल रहा है, means it is very, very negligible ना. 0.000 point क्या होगा? 0.0000001, बहुत ही कम, राइट? मतलब कॉन्सेंट्रेशन ऑफ मेन वाटर पे कुछ फर्क पड़ रहा है क्या? जैसे 1 बकेट समुंदर से निकालते हो तो समुंदर के पानी पे कोई फर्क नहीं पड़ता है, तो 1 मोल में से 10 to the minus 7 अगर निकल जाते तो कुछ फर्क गिरेगा नहीं ना. So that means the concentration of water molecule are considered as a, that means the majority of water molecule are considered as a undissociated water molecule. Barabar? Means large amount of water molecule remain in the undissociated form. So that's why the concentration of water considered as a constant, and that means इसका meaning क्या है? The concentration of water not change because of negligible amount of water molecules are undergo dissociation. So the large amount of water molecule remain in undissociated form. So that's why the concentration of water is considered as a constant. Understood? Now, this concentration of water, that means concentration of H2O, is considered as a constant. So which is denoted by a K dash. Now put this here in this equation, this value of H2O, concentration of H2O as a K dash, put here. So the equation become K into K dash equal to concentration of hydronium ion and a concentration of OH minus ion. Now this constant, one constant multiplied by another constant gives new one constant. Okay, K is the equilibrium constant, K dash is the considered as the water or concentration of water as a constant. So these two constant produce one new constant, and this new constant is denoted by Kw. Okay, now this new constant is denoted by Kw. So the equation become, this equation become Kw is equal to concentration of hydronium ion into the concentration of OH minus ion, and this Kw is called as ionic product of water. This Kw is called as ionic product of water. Understood, student? What is the meaning of ionic product of water? What is the meaning of equilibrium constant or the ionization of water? I hope सबको समझ में आया होगा. So this Kw is called as ionic product of water. So how will you define the ionic product of water? क्या है वो ionic product of water? It is the product of, किसका product है? Product of concentration of hydronium ion or H plus ion. H plus ion, that means hydrogen ion. It is the product of concentration of hydronium or hydrogen ion and hydroxide ion at equilibrium condition, right? In pure water at a given temperature is called as ionic product of water. I repeat, the product of molar concentration of hydronium or hydrogen ions and hydroxyl ion at equilibrium. Equilibrium condition is very, very important because all those terms happen at equilibrium condition in pure water at a given temperature is called as ionic product of water. Okay, is called as ionic product of water. Now because of that, means the concentration of H plus ion is found to be 10 to the power minus 7, and similarly for hydroxide ion it is 10 to the power minus 7. That means it is very, very negligible. In which water? In very, very pure water. So it is H plus ion and OH minus ion concentration is very low na, very small na. So that's why pure water is not a good conductor. Okay. So in pure water at room temperature, now at 298 Kelvin, and 298 Kelvin, that means how much degree Celsius? It is around 25 degrees Celsius. So which is considered as a 25, which is considered as a room temperature. So in pure water at room temperature, the concentration of hydronium ion and the hydroxide anion are always equal. As I told you earlier, it is almost 1 into 10 raised to power minus 7 mole per liter. That means 1 liter of water. ठीक है, 1 liter of water, whenever it undergo ionization, it produce hydronium and hydroxide ion, and having the concentration is 1 into 10 raised to power minus 7 mole per liter. ओके, कितना कॉन्सेंट्रेशन रहता है? 1 into 10 raised to power minus 7 mole per liter. So as we know, the ionic product of water is, क्या रहता है ionic product of water? It is the concentration of hydronium ion into hydroxide ion. So the values of hydronium ion and hydroxide ion concentration is 1 into 10 raised to power minus 7. Put this here. करो वो इक्वेशन में ये वैल्यूज को पुट अप. सो कर दिया. H प्लस हाइड्रोनियम आयन का कॉन्सेंट्रेशन है 1 into 10 to the power minus 7. सिमिलरली हाइड्रोक्साइड आयन का भी वैल्यू है 1 into 10 to the power minus 7. So as we know, 1 into 1, 1 remain. 10 into 10 means 10 raised to the power minus 7 into 10 raised to the power minus 7. क्या करोगे? 10 raised to the power minus 49. Wrong. Whenever a power is there and 10 raised to the power x या ऐसी कोई टर्म होती है जो कि मल्टीप्लिकेशन आती है तो पावर की एडिशन होती है. सबको पता होगा, बीइंग अ स्टूडेंट ऑफ मैथ्स, ये सबको पता होगा कि 10 टू पावर x इंटू 10 टू पावर y, ऐसी कोई टर्म है तो उस पावर्स की एडिशन होती है. सो 10 टू पावर x प्लस y होगा, राइट. सो हियर आल्सो 10 टू पावर माइनस 7 इंटू 10 टू पावर माइनस 7, दैट मीन्स 10 टू पावर माइनस 14. So the value of Kw is obtained as 1 into 10 to the power minus 14, and this is the value of ionic product of water at 298 Kelvin in pure water. Okay, and this is universal value. Always remember, the value of ionic product of water is 1 into 10 to the power minus 14, and the value of hydronium ion and hydroxide ion in pure water at room temperature is 1 into 10 to the power minus 7. Understood, student? I hope सबको समझ में आया होगा. Is that clear? So this is called as the ionic product of water. Okay. Now the next topic is pH scale. Again, this is very important and basic topic. Now pH, that means potential of hydrogen. Long form of pH is potential of hydrogen. हाइड्रोजन का पोटेंशियल कितना है इन सॉल्यूशन, दैट इज कॉल्ड एज द पीएच. हाइड्रोजन का पोटेंशियल इन सॉल्यूशन, हाउ मच अमाउंट इज देयर, दैट इज कॉल्ड एज द pH. Okay. Now, as we know, the concentration of H plus ion in pure water is 10 to the power minus 7. अब आप लोग बोलोगे मैडम आप तो 1 लिखना भूल ही गए. 1 into 10 to the power पहले की स्लाइड में तो आपने ऐसे बताया 1 into 10 to the power minus 7. सो अरे बच्चों, 1 से आप किसी भी टर्म को मल्टीप्लाई करते हो तो वो कुछ चेंज नहीं करते. सो 1 into 10 to the power minus 7 लिखो या only 10 to the power minus 7 लिखो, मीनिंग इज सेम, right? So as we know, the concentration of H plus ion in pure water is H plus ion or hydronium ion. Both are same, H plus ion or hydronium ion. So concentration of H plus ion and hydronium ion in pure water is 10 to the power minus 7. Similarly, hydroxide ion is 10 to the power minus 7. Right? So 10 to the power minus 7, 10 to the power minus 7. Every time speaking 10 to the power minus 7 बहुत difficult है ना. 10 to the power, 10 to the power कितने बार बोलोगे? तो उसको एक सिंपल सॉल्यूशन में कन्वर्ट किया गया है. किसने किया है ये सोरेनसन ने किया है. दिस इज, ये जो यहाँ पे फोटो दिख रही है ना आप लोगों को, ये है अपने सोरेनसन साइंटिस्ट. ओके, जिन्होंने पीएच का फॉर्मूला और पीएच स्केल को डिस्कवर किया है. ओके, बिकॉज ऑफ दैट very difficult wording of 10 raised to power minus 7, 10 raised to power minus 7. Okay, so the H plus ion is, the concentration of H plus ion is very small in aqueous solution. ये तो सबको पता है, right? Or which can generally express this concentration of H plus ion in terms of pH. Now, because of this wording 10 to the power minus 7, 10 to the power minus 7, अगर उसको कोई सिंपल सॉल्यूशन में कन्वर्ट किया जाए तो इतना बार बार बोलना डिफिकल्ट नहीं जाएगा, राइट? तो ऐसा ही सोरेनसन ने थोड़ा सोचा होगा, एंड ही गिव ए स्केल that is called as the pH scale, and he also produced one of the formula of pH in the year means in the year 1909. Okay, and define the pH of solution. Define the pH of solution. क्या है definition? As the negative logarithm to the base 10 of the concentration of H plus ion in solution. Solution is mole per dm cube. Okay, solution in mole per dm cube. कितना mole per dm cube solution में the concentration of H plus ion क्या रहेगा? It is the negative logarithm to the base 10 of concentration of H plus ion. So the formula become pH is equal to minus log to the base 10 concentration of H plus ion. This square bracket is called as the activity और उसको हम लोग बोलते हैं concentration. So this square bracket is called as the concentration. So H plus ion is present, so that is called as the concentration of H plus ion. Similarly for POH, that means potential of hydroxide. So formula become POH is equal to minus log to the base 10 concentration of OH minus ion. These two formulas are very important and always remember that. ये आगे आपके काम में आने वाले. pH is equal to minus log to the base 10 H plus ion concentration, and POH is equal to minus log to the base 10 concentration of OH minus ion. So how to define the pH? pH को define करने के लिए कैसे करोगे? So pH of solution is defined as the negative logarithm to the base 10 of concentration of H plus ion in solution, and POH is defined as the solution as the negative logarithm of the base 10 of the concentration of OH minus ion in solution. Okay, so this is called as the pH and POH. Formula of pH is minus log to the base 10 concentration of H plus ion, and for POH the formula is POH is equal to minus log to the base 10 concentration of OH minus ion. Now let us discuss about the relation in between pH and POH. This is very important topic. Relation in between pH and POH. What will be the relation? pH और POH कैसे एक दूसरे से relate करते हैं? Now as we know, the ionic product of water क्या रहता है? Kw is equal to concentration of hydronium ion and the concentration of OH minus ion, right? So this is called as the ionic product of water, and as we know the value of Kw is found to be 1 into 10 to the power minus 14, right? Kw is equal to 1 into 10 to the power minus 14. Now the value of Kw is 1 into 10 to the power minus 14, तो Kw की जगह पे मैंने ये लिख दिया नेक्स्ट इक्वेशन में. क्या लिख दिया? As we know, value of Kw is concentration of H3O positive and concentration of OH minus ion, and also Kw is equal to 1 into 10 to the power minus 14. So rearrange this equation. क्या किया मैंने? ये Kw की जगह पे ये वैल्यू लिख दी. राइट हियर दिख रहा है सबको? सो यहाँ पे क्या हो गया इक्वेशन? Concentration of hydronium ion into the concentration of OH minus ion equal to 1 into 10 to the power minus 14. ये क्यों किया है? because we will creating a relation in between pH and pOH, right? Now the next step is taking logarithm on both sides of this equation. On both side मतलब both side में logarithm ले लो, and as we know जब भी log अप्लाई होता है मल्टीप्लिकेशन फैक्टर में वो पॉजिटिव हो जाता है, राइट? सो यहाँ पे क्या होगा, ये जो मल्टीप्लिकेशन वाला है H3O पॉजिटिव एंड OH माइनस एन, वो क्या हो जाएगा, प्लस में कन्वर्ट हो जाएगा बिकॉज ऑफ अप्लाइंग ए लॉगरिथम टू द बेस 10. Okay, so log of hydronium ion plus log of hydroxide anion equal to -14. Now look here, ये -14 कैसा आया है? अगर मैं यहाँ पे log अप्लाई करती हूँ, ठीक है, log of वन इंटू 10⁻⁻14. ओके, यहाँ पे ये लॉग होगा. नाउ ये लॉग दोनों को रहेगा, ये 1 को भी लॉग रहेगा और 10⁻⁻14 को भी रहेगा, और मल्टीप्लिकेशन साइन इज कन्वर्टेड इनटू ए पॉजिटिव साइन. सो द इक्वेशन बिकम log of 1 plus multiplication converted into a addition, log of 10⁻⁻14, right? Log of 1 is 0 plus, now see here, ये आपको पता है कि अगर कोई भी टर्म का लॉग है, लॉग ऑफ 10⁻x अगर ऐसी कोई टर्म है इन मैथ्स, तो उसको सॉल्व करते समय ये जो पावर है वो सामने आ जाता है, राइट? सो तो क्या बनता है फिर वो x log of 10 and log of 10 is 1, right? Log of 10 क्या आता है? Log of 10 is as 1. So x into 1 that means x ना. So here also ये जो 10⁻⁻14 है वो क्या आ जाएगा, नीचे आ जाएगा. So माइनस साइन के साथ वो नीचे आ जाएगा, right? And into 10 into log of 10 मतलब क्या, 1. So the equation, what will be the final value? 10 final value is obtained as a -14. So ये -14 यहाँ पे आ गई. Understood? This is very easy. जो मैथ्स के स्टूडेंट्स है आप लोग तो आपको समझ में आ ही जाएगा, ठीक है? दिस इज द डायरेक्ट टर्म. So this become 10⁻⁻14. Now next step is multiply both side by -1. ये जो टोटल इक्वेशन है दोनों साइड में इसको क्या करना है, मल्टीप्लिकेशन करना है, किससे, -1 से. तो करो इसको, ये प्लस में है, -1 से मल्टीप्लाई करते हो तो क्या हो जाएगा माइनस, ये भी प्लस में तो माइनस से मल्टीप्लाई करते हो तो प्लस साइन हम लोगों ने रख दिए बाहर और ब्रैकेट में लिख लिए माइनस. ओके, एंड दिस इज ऑलरेडी इन माइनस फॉर्म and into -1 करते हो तो as we know minus minus become plus, so this is become plus 14. and as we know, now see here, ये कुछ जाना पहचाना लग रहा है, माइनस लॉग H3O पॉजिटिव माइनस लॉग OH माइनस, कुछ तो भी जाना पहचाना लग रहा है, ऐसे लग रहा है इसको देखा है कहीं तो भी. कहाँ देखा है जरा याद करो. इसके पहले की स्लाइड में हम लोगों ने ऑलरेडी पीएच और पीओएच को डिफाइन किया था. क्या था पीएच, minus log to the base 10 H plus ion concentration. pOH is minus log to the base 10 concentration of OH minus ion. So here also ये जो log है ना, this is the to the base 10 log है, हाँ, log to the base 10 ही है. So this is hydronium ion that is called as pH. This is minus log of OH minus ion called as pOH. So we can find a one more equation that is nothing but a pH plus pOH is equal to 14.0. That means this minus log to the base 10 H3O positive is nothing but a pH, and this is ये क्या है, pOH. So इसके जगह पे pH लिखो, इसके जगह पे pOH लिखो, हो गया इक्वेशन इक्वल टू 14. and this is the relation in between pH and POH. This is the relation in between pH and POH. What will be the relation? pH plus POH is equal to 14. Remember that. Okay student, this is the relation. Okay, कुछ भी नहीं है. It is very easy. Firstly, you have to write the ionic product of water, that is nothing but a Kw is equal to concentration of hydronium atom into the concentration of OH minus atom. As we know the value of Kw. क्या रहती है Kw की value? It is 1 into 10 raised to the power minus 14. So the value of Kw and the value of another Kw, compare करो दोनों को. So the equation become concentration of H3 positive into the concentration of OH minus atom equal to 1 into 10 raised to the power minus 14. Now the next step is taking logarithm on both sides. अब यहाँ पे जो logarithm use कर रहे हैं वो to the base 10 ही है. दोनों साइड में लॉगरिथम ले लो, हो जाएगा. इसको यहाँ पे लॉग अप्लाई होगा, मल्टीप्लिकेशन कन्वर्टेड इनटू पॉजिटिव चॉइस एडिशन. और इसको कैसे सॉल्व किया ऑलरेडी मैंने आपको बताया है कैसे सॉल्व किया उसको. सो द फाइनल वैल्यू ऑब्टेन इज -14. अब अपने को माइनस नहीं चाहिए, -14 नहीं चाहिए, तो हम लोग क्या करेंगे, अपने को रिलेशन क्रिएट करना है ना पीएच और पीओएच का. तो यहाँ पे कहीं से तो भी पीएच और पीओएच को लाना पड़ेगा, तो ही रिलेशन क्रिएट होगा. सो कैसे लाएंगे? So multiply on both side by -1. -1 से मल्टीप्लाई करोगे तो लेफ्ट हैंड साइड वाली टर्म पूरी नेगेटिव हो जाएगी एंड राइट हैंड साइड वाला जो -14 है इट बिकम पॉजिटिवली चार्ज. राइट, एज वी नो and according to definition of pH is equal to -log to the base 10 concentration of hydronium ion. So this is called as the pH. And pOH क्या होगा? It is the negative logarithm to the base 10 concentration of OH minus ion. So that is nothing but a pOH equal to 14. So we get the relation in between pH and pOH as this. That means pH plus pOH is equal to 14. Understood student? I hope it बहुत easy topic था, सबको समझ में आया होगा. If you have any queries, you can ask me. Now, so this is all about the relation in between pH and pOH and the ionic product of water in autoionization of water. In next lecture, we will discuss about the hydrolysis of salt. Okay, in next lecture. So till then, all of you stay safe and stay at home. Okay student, chalo bye.